I'm going to talk about React Server components. My name is Jonas. I'm a freelance developer. I'm mostly teaching teams for modern front-end technologies and also helping set up new projects and setting up teams with modern front-end technologies. I'm going to talk about React Server components. React Server components is actually not that new. They were announced in 2020, and I was amazed. But then there was a void, and nothing was going on. And now they were introduced with the framework Next.js in version 13, October in 22. And other frameworks announced that they are also going to support React Server components. So React Server components is very controversial. So some people claim that this is the death of React. React is getting too complex now, and they are leaving React because of server components. And we will have a look at it. What's that whole thing about? But first, I would like to know who is a React developer or who is working with React. Okay, that's a lot of people. That's nice. So I still want to have a baseline. I'm doing a short refresher. How I think we are all used to how we do React development today. So, what was that? The baseline I'm just having here a single page application React project. It's created with Vite, and it shouldn't be that much of a surprise. So I have this app component, and I am actually looking at it, and this app component is using a greeter component here inside, and the greeter component here, that's the interesting part, he is logging out when he's getting rendered, and that's probably what you are expecting. We are seeing that it is going to be rendered down here in the browser console. So that's how we do React development. We ship JavaScript into the browser, and then we execute the components in the browser. The components modify the DOM in the client, and we see some UI here. What I also did is I have some API here. This is just a simple HTTP API here that serves some data. The data comes actually from a database. I have the database over here with some text in it, and we see this is actually coming via an API call into the single page application here. We see this network call if we look at the network tab. Let's make that bigger, like this. And then we see that there is a network call that gives me this data, and we see there's a time where it is loaded, and it takes some time until it is rendered in the single page application. And that's also, so that's what we know. React has a composition model. I have an app. The app uses a greeter. The greeter has the possibility to use some hooks, and I am using these composition models. I think that's the strength of React. We have really this very elegant composition models, composition of components, composition of hooks. They caused a very easy and powerful programming model that made React so strong as it is today. How is that working in the background? So we have the component model. Component model is executed in the browser on the left side, and then we have this concept of the virtual DOM. So the component, they render into the virtual DOM, that's in the JavaScript memory, and then the virtual DOM is actually reconciliated, rendered into the real DOM. That's how React works. That was the reason why React was some years ago very a performant framework. Today the virtual DOM is not characteristic for being performant. And that's how we deal with it. I think we should be familiar with that. The thing that's not so nice is when it comes to data access. So this is probably the idiomatic data access. When we just use React and no other frameworks, we have to use this kind of effect with the dependency array, and then we have to cancel the request if the component is unmounted and stuff like that. So that's not so nice. I hid that behind a hook in my case. This is this in the component, the greeter component, I have this use data API, and you see this code here that is dealing with that complexity. We also have this other API with suspend. So this is like inversion of control. Instead of having a message text that's first empty and then later it has something and then the component is re-rendered, we can also go this way here. This should work the same way, but now you see, when I load that, the whole component is not rendered until the data is there. So with suspense, the component actually yields and says, I'm not yet ready, and the parent of the component, that in my case it was the app, he has this suspense boundary around the component, and he says, okay, I'm waiting until the greeter is ready, and then I'm re-rendering the greeter again. Okay, so that's how a traditional single-page application works. That's also very similar if we would do Vue or we would do Angular. So if we are now talking about the server, most of the people probably think about server-side rendering. So I also have the same project realized with server-side rendering. It looks exactly the same. But the only difference is this one. If you look here, we already get a rendered application from the server on the first request. So I didn't show that one. I go over here. If you look here at the document request, then we see basically an empty page. And the page is only rendered after the JavaScript has been loaded and executed. Traditional single-page application. And now, with server-side rendering, we already get an initial rendering on the server, and then later all the JavaScript hydrates the application and makes it interactive. But this talk is not, so this is traditional SPA, this one is server-side rendering, we get already a screen, it's hydrated later on, and the characteristic, maybe also that's important here, we see it's loaded on the server, or executed here on the server. We see this greeter is rendered on the server, but it is also initially rendered on the server. So let's say it's rendered on the client, and it's also initially rendered on the server over here. But this talk is not about server-side rendering. Server-side rendering is a solved problem, probably. All the modern front-end frameworks can do server-side rendering. React Server Components is not about server-side rendering. That's the confusing thing about the term. React Server Components is an architecture. And now I want you to forget everything you know about React for a moment. Because I could now try and say, okay, now you have seen this client-side React, and now I try to explain how server-side React server components works together with that, but that's not what I'm trying to do. I want you to forget everything you know about React and to be open. I will show you now something, and this now something, this I'm calling React Server. And I'm explaining you what React Server does. So for that, I take the next project. What we have here is an application, React Server. It renders a React Server here. And if you look at the source code for that here, we have a component that looks like the component before. This is my home component. He renders an H1 React Server and the current time. But when we look at the rendering model, so we see that if I refresh the page here, there is no output down here, even though we do a console rendering. But we see it is rendered here on the server. This is a React Server component, and it is only rendered on the server. That's the difference. There is no hydration going on. The JavaScript code is not even shipped into the browser. It's just executed on the server. So that's probably meaning that we also see the fully rendered application if you do a refresh. So let's go here and have a look at that. So if we go on the first request here and do a refresh and look Let's have a look here, refresh for the whole thing and see what that's coming on. We see that the page is already rendered from the server. Not so surprising. But now, what's going on if I navigate to the simple, to the second route? So on the second route, I have a second React component. Also, this second React component, he renders, he logs out on the console and has a display of greeter. And now if I go here and I navigate from my index route to my simple route, you see it's doing an update. And still, you don't see any rendering or the console output on the browser. You see the component was rendered on the server, but not on the client. And if I navigate between these two routes, we see it's a single page application. Only parts of the DOM are updated, but actually the component is not rendered on the client. So how does that work? When we are doing client-side rendering, we have our code, and we have this virtual DOM. I call this the React Client Runtime. And the JavaScript code is executed in the client, and it updates the virtual DOM, which then updates the real DOM. But if we have a server component, we render some instructions in an intermediate format on the server, and then we ship that instructions to the virtual DOM, which is running in the browser. So the client runtime has been loaded. And then these instructions are manipulating the virtual DOM, which then updates the real DOM. And that's also what we see here when we look a little bit. I don't want to look too long into that, but if we look at the network requests when we navigate here, then we see there are some fetch requests going on, once again. So, and when we look at those fetch requests, we see some intermediate instructions, some intermediate format. That's this intermediate format that's going from the server to the client, manipulates the virtual DOM or the runtime, and then updates the UI. So this is a single page application. I call this server-driven spas. Other people are calling this live view. There are other frameworks which are doing the same thing. In the Java space, there is Vadin, which has a similar concept. In the .NET space, there is the Blazor server execution, which does the same thing. Or there is a framework that's called live view from Phoenix. Other frameworks are doing that. So let's have another look what we can do now that we are here. So when we are on the server and we are rendering on the server, maybe we can profit from that. So on the server, we have access to server resources. Let's have a look at that. So here, I have a route that says this is server data. Let's have a look at this one. I'm switching to the other browser again. So here I have a server component now, this backend component. And this backend component, he executes just a function which is imported from somewhere. And if you have a look at that, this one is actually presenting me some data, and it logs out and it returns the data. And we see it is actually logging this on the server. This is server data here. Now we are on the server, so we can do other stuff. So we could go here and say, what's my current directory? And we have the current directory. Or I have a file here somewhere, server data, hello from file. Let's add something, voxed, something like that. And then I go in and I say, okay, I want to actually read that file. Okay, now I have a little problem because reading a file in JavaScript is asynchronous. So I want to use a wait. I can't, but the solution is easy. I am going up and say, okay, this is an async function. So I can do a wait, but now I go back into my component, and then we would see this one is now getting a promise. But don't worry, I can also say this is a wait. And then, oh, okay, I also make my component async. and the whole thing works. And if we compare that to the use effect dance we had before for loading data, this is pretty amazing, I think. Oops. So we can just have async functions on the server. They are rendered on the server. They wait for some resources from the server, and then I can actually render them into the data into the client. One more step I prepared here. My server data also can actually query the database, so we are on the same page then as before with the API. So I say in the get data, I don't want to read it from the file, but from this get data, and this get data here, this basically makes a SQL query which goes to the database and gets some data. And if I do the refresh, I get here hello from DB. That's the actual value I have here in the table. So this can be tempting, I think. So let's investigate a little bit further. What if we would do that if the request is actually a bit slower? So I introduce a random delay here, which takes a while until my read server data actually returns some data to my client, to my component. And if you now render here, you see it's going on a little bit. It's not so obvious if I do not the navigation. So I'm going back to the simple one, and now I click. No. Once again, now I click, I go back, now I click. Did I click? And now it did render. I go back, now I click, and now it renders. So that's obviously not so cool, and we are in this request response model that we know from the old school web programming. So let's see what we can do here. So we have seen in the client components, there was this suspense boundary where I could, on the client, say, okay, if a component is not ready, he can actually signal that he is not ready, and the parent takes over again and waits until he is ready. Let's do the same on the server. I'm going on the parent component from my backend component, and I just wrap that whole thing in a suspense block. And now you see, it's loading. And still, nothing is rendered on the client, just rendered on the server. So how does that work? React Server Component can be streamed. And modern browsers can stream. So the HTTP response actually returns the HTML that is ready, or the markup that is ready, that is already rendered, and then a little bit later on, it delivers some more chunks when they are ready. And this is delivered as some HTML blocks and some scripts, and the scripts then update the chunks in the UI. So that's one of the features of React Server Components. They are streaming from the server to the client, so they can still have a good feeling for incrementally updating UI. What about if we have 4 of those backend components and I have a random delay now? So if we go here and would look at that a little bit, then we see if I navigate away from the backend and then here, then it's waiting until every one of those is ready. And now everyone can be rendered. But we can make that even more fine granular. I'm not live programming this, I'm just showing you the code now. We can go in and say we have a suspense boundary around all of those backends. And then we can incrementally update the UI. Now it comes in when it is ready. Still, everything is rendered on the server, nothing is rendered on the client. So when we look at this, when I saw this the first time, I was pretty amazed. So when we are coming from a background of React programming, this is quite something new. But maybe if we are coming from an even older context, this is not so special. PHP could do that before, 20 years ago. So we are server-side rendering. What's the thing about it? That's from the Stone Age. So we are not finished. So prepare from some more amazing things coming up now. But first, let's talk about the limitation of that whole thing. The limitation is we are rendering on the server, so we don't have any interactivity on the client, apart from that what I showed you with the streaming, which is incrementally happening, and the updating of when we do a routing, which is driven by the server. So technically, that actually means in server components, they are only rendered on the server. We cannot use a lot of the stuff we are used to from React programming. So we cannot use hooks, we cannot use state, because state would mean re-rendering on the client. We cannot use event handling, and of course we cannot use some DOM APIs because we are running on the server, basically. And now, you can restore your memory about React programming. We can combine the whole thing. So what I'm showing you now is here a clock component. This clock was rendered on the server, and it showed me the time was rendered here on the server. It showed the time over here. Nothing was rendered on the client. But what if I would like a clock that actually updates every second and shows me that the current time? So I would need some client-side functionality, like an interval that's running in the browser. Let's have a look at the clock. So this clock is, oops, I wanted to hide some crazy stuff here. This is just a component as we know it from React programming, and it's rendered on the server. But we can just go in up here and say, use client. That's a directive. And now we have a client component. And we can do everything we wanted to do when we were doing React programming before in the single page application programming model. So let's play a little bit with that now. Now we have server components, we have client components. We can combine them. First slide. Exactly, so this was a use effect that updated the time. The important thing is client components are opt-in. So everything is per default a server component, and I have to say I want to use a client component now. I want to have lifecycle, I want to have state and stuff like that, and I do that by putting that directive on top. And the client component, again, is rendered on the server and on the client for the initial rendering, as we had it before with server-side rendering. If you realize that, if we do here the clock, then we see the clock is still, it's a client component now, it's still rendered on the server for the initial rendering, so that we have some rendered HTML that can be shown, and then later on again for hydrating on the client. So let's play again with, there I have a counter. Let's see what I have. The next one is a counter. I want to implement a counter. There is no demo without a counter. So let's go here and demonstrate that. This counter is rendered on the server right now. And if I want to go in and say, I want to have state now, then actually I get an error. And it says to me, you are using use state, and you are you need to be a client component to use state. That's what I told you before. So actually, we make a client component out of that component, like this. And now he is happy. We can have our use state, and then we can also implement our functionality. A button handler. We attached on click handle on to my handle click. And we actually want to render our count like this. And we have our counter like we did it for ages in React. That's not that interesting, but you see, now you can leverage everything you know about React. The other thing that was just something new. So now we have React plus the traditional components, and that's what they call the React server component. So this is a React server component. Let's dive deeper into it. We go into composition. Now we have client, we have server. How can we combine them? So here I'm starting with just a container component. Let's have a look at the source code. This container component is rendered on the server. I just see that rendering here and nothing down here in the console. Then I have a child component. The child component is a client component, use client. And I'm rendering the child component from my container component by just going in here and saying, I want to render my child. As we know it. So, server components can render client components. Now I have a third component, I call it here shared component, and I'm not telling anything here. What did I do here? I'm not telling here if it is a client component or not. I just have a component as we would do it traditionally in React. And now I am importing that shared component from the container component. I go in here and say, okay, I have here my shared. And what we see now, this is rendering on the server. If I import a shared component into my child component, which is a client component, then we see this is rendered on the client. Also, it's a client component. It's automatically a client component now. It's rendered for the initial rendering on the server, but then also rendered on the client. So basically, the use server that we have here in our child component, it demarks a network boundary. And once I go into this network, over the network boundary, everything that's imported from the client component is also a client component. Technically, this means the bundler has to be smart. So there is a bundler going on, and he sees every client component is an entry point if you think about Webpack or how the bundlers work. Every client component is an entry point, a bundle is created, and from that bundle on, you can have other trees, other functionality, which is then in the bundle, which is shipped to the client. And then you have a third composition pattern. You can go in and say, okay, I have my child component. I actually want to receive a component as a property. So from Angular, this is content projection, or this is children, or property in React, or slots in Vue. So if we go in, we can actually now make it like this. We can go into our container, and we can say, okay, I want actually to nest my shared component into my child component. So the shared component is still a child of my container component. So it is a server component. It is rendered on the server. The client component is later on rendered on the client. But it still can have this slot, this hole, where the server component will be plugged in. So let's have here a look. Of course, I have to go into the child and actually use that children here. I go in here and I'm saying, let's do both of them. I want to have the children here. And then you see the first child up here. That's the one that I'm rendering from the child, the first shared. That's a client component. And the second one here, that's the one that's actually a child of the container, and it's rendered on the server. So the mindset is thinking about those trees. So we have a server tree and we have a client tree, and they can be composed in different ways. And in the middle, I have the one that is actually rendered on the server, but it is passed as a children, as a property to the child. So we could also imagine like the server tree is rendered with some holes to the client, then it is rendered on the client, and on the client, those holes are filled with client components. And the other way around. And now it's really getting interesting, because now we have a component tree that spans client and server. What about data flow? Data can flow through the component tree. Let's experiment with that. So we have here this data flow example. I have a container and that I have a child. The container renders the child, and if you look at the child is a client component rendered on the client. So we go into the container and we actually want to to load some data again. So I wanted to have, let's go now. So I wanted to query my database in the container. So this is running on the server. I can query my database. We have used that in previous examples. I could actually render that here somewhere. Data from the DB. Something like that. And then when it's done, we see something here coming in, but that's not the thing I want to do. I want actually to pass that data to my child component. So this has a he can receive a property, and I give him the data from the DB. And now it's rendering, it takes some time, and now the client is rendering the data that is loaded on the server from the database. And again, this takes some time, so because we are waiting here, this child is only rendered once the data is here, so that's the thing that we see now. If we go from home to data flow, I clicked it and it took some time until it is rendering because of the asynchronity, as we have seen before. So let's have a look at the child once again. So the child is just the programming model is that the thing that we know. Let me go in from from React. I just receive a property and I render my property. But this property is crossing the network boundary now. So we pass property from parent components to child components as we are used to, but now we have a distributed tree. So the property is actually traveling with the payload from the server to the client, and then on the client passed to the client component. And again, if you didn't believe it before, we don't need an HTTP API. And it is arguably simpler to pass data like this. And PHP couldn't do that. So now we crossed that. Let's improve the example a little bit, because we don't want to wait until the thing is ready. So I'm going in, and in my parent component here, I am extracting the logic that actually loads the data. So I make an intermediate component here, this content component. I don't query the database up here, but in this content component. And then here I'm just rendering the content component. And I'm wrapping that again in the suspense boundary. So almost, what's the problem? Multiple times. Oh. So, and now you see the content is already rendered, and a little bit later on, when the payload is streaming the property, then the client is also rendered, and he can get that property. I think that's quite amazing. So let's go further. Last topic. Last topic is now there is also something that's called server actions. Server actions is now the other way. Until now we had just been fetching data. And we have seen an elegant way to actually pass data from the server to the client without having to write an HTTP API and think about how the thing is serialized and which verbs we use, get, put, post, delete, and stuff like that. Server actions is now the other way. Server action is now when I am the client, I want to actually make some mutations on the backend. There is also a part of React Server components. This is also a part of the React Server components, and it's called server actions. And this is now going, if you're not confused until now, this is probably going to be confusing. So let's have a look at this demo, how I started it. So we have a container component. And the container component is just rendered on the server again. That's a server component. There is no rendering happening of components in the client up here. But I can go in and I can update my my data. This is in the database, so if I'm going into my database here, I can query my counter. And you see this is this value, 551. And if I go up a little bit here, then we see this is actually updating my database. So let's have a look at the code. We are in the container component. And what we have now is something that's going to be confusing. That's this function here inside my component. So I have a container component. He renders a form, and the form has an action. The action calls a method or a function, and this function is going to update my database. And this has this declaration here, use server. So this is a server function and has access. Oh, this is code that runs on the server and it has access to the database. So I can do update count in the database, and if we go inside here, then we see somewhere in here we access the database and we are doing something with the database. And then we revalidate the UI on the server. So again, the payload is generated on the server, which says how the UI should update it. So with one call, we can actually go in and do the mutation on the server. And we also get the instructions back how the UI should be updated so that this counter is actually reflecting the new value from the database. This is not an optimistic UI that updates somehow the UI and sends something to the server, but this is updated on the server and the server tells me how this should be updated. So again, if you go into the elements here, we see that this is a fine granular update somewhere inside my body, somewhere here. If you do the update, just that thing is updated. So the confusing thing is this use server. So there were a lot of memes when they introduced that, and they said, oh, isn't that dangerous? And so you are on the client and you're doing SQL from the client to the server. No, no, no. We are in a server component. So all that code is running on the server and is not leaving the server. That code is not shipped into the client. So why do we need that use server? What does that mean? That use server means that the framework generates an API endpoint that can be called from the browser. Not from my code in the browser, but from the DOM that's rendered in the browser. And automatically generated is an endpoint that can be called. So that's why it's called use server. So how does that look like? So this also contains the next examples, but I'll show you like that, the uppercase here. We have the server component that's rendered on the server. We also have the use server function that's also executed on the server. Then when we render the server component, it travels to the browser, and in the React runtime, we then call this API endpoint on the backend again. So there is an HTTP call. Minus 5 minutes, only 5 minutes, yeah, that's okay. It's going to call there. So that's how it works. So actually, if we are looking at these two directives, use client and use server, they are always about network boundaries. Use client means that we have an entry point for some from the bundle, and we ship some JavaScript over the network to the server, to the browser. And the use server actually means this is some code that can be called from the client over the network. So let's a little bit play with some other scenarios. Or one more thing that's really amazing here is if you think about how that works, we are actually calling from the browser a function, and in that function I'm accessing the data that I loaded from the database when the component was rendered on the server. And this is stateless. There is no session involved here. So the closure of that function here is serialized to the client. And then the client has, if you look at the payload, we would see this is encrypted in the payload somewhere. The client has the closure and then passes that back to the server once this method is called. So that allows me to actually have the context of the server component again when I'm coming back from the browser to do a mutation. But that is not the only way. We can do another way. We can go in and play with that now. One other option would be we have an input field here, and I would call another method here. Count server, like this. And now if we render that, we have a nicely styled input here, and I could go in and add something and update my UI again with that value that we have here. And this then works a little bit different. So here we don't have that closure thing. We just have a function that's marked as use server, and it's also not in the same file. This is another file, server data. I called that, or I could call it API or something. And this is just also saying, hey, this gives an endpoint that can be called from the browser, and then I have the logic in here. And this receives the form data because it's attached to a form. I get the form data, I can read the data from forms, and then I update again my database. That is another option that I have. Still, everything is run on the client, on the server. I can also put that directive on top, and then everything in that file, that's probably then a good pattern, everything in that file is methods that I can call from over the network from the browser. But let's make it a little bit more interesting, and that's the last demo I have. Let's say we also want again to render our child. And our child, which is rendered on the client, should have an update button. So now we can go in and we can actually call a server function from the client. We can just import that, sorry, I already did import it. And we could import that method again from this server data file, which is marked as use server. And we can go in and then update count server with value, call that. And then we can use state and client-side interactivity to actually call that method. We could call that as part of a life cycle, or we could call it on a button handler or something. That's the thing that I'm going to do now. Right now I have the handle click here, and if we go on the console you would see that I have handling click here, but now in the handling click I'm going to update this with something like new date get milliseconds so that I have a random value, and now when I update you see it updates my thing, my UI. So we can call server functions also from client components, and the last thing, we're going back to the data flow mechanisms. We can even pass functions as properties from server components to client components. And then we can again use the closure from the parent component. So that's really the last demo now. We have the container component. We are currently not using the update count anymore. But what I'm going to do now is the following thing. I'm going to put that as a property, as we are used in client-side React programming. I have here an, how did I call it? Oh, no, I didn't call it. So I'm going in and I'm defining here a prop which I want to receive. And I say, okay, this client component, this child component here can receive an update function. And then when it gets this one, I actually want to call this one. And this doesn't take any arguments like this. And then I'm passing it in here and say, okay, I want the update function. I'm passing the function from my server component into the client component. So, and now if I update, I'm increasing again from the client component. So if you didn't believe me, you really don't need an API, also for mutating. There are some new hooks. We don't have time to look into that. So if you are in the client component and you're working with server actions, there are new hooks to get the pending state and showing a spinner, for instance, or to get some feedback back from the mutation, like error handle, error messages or something like that. There are new hooks, and also for optimistic updates on the client, in the client component. So that was about it, my summary. What is React components? The React server components. It's primarily a full stack architecture. It's based on the proven component model of React. So that's the power of React, and you still can have that power. And also I think there is potential for giving a huge ecosystem. React is thriving right now because it has such a huge ecosystem. It's very easy to just take a component somewhere from NPM, put it in my tree, and everything is working. And they are extending that to the server now. I can just take a library from NPM and can put it in the server tree and maybe have data access or third-party modules which are talking to some services or something. They are living in my server-side component tree. Everything is working. It is also like an official answer to the data fetching problem in React by providing some transparent remote procedure calls. And finally, and that's the thing that we also get, but I think that's not the whole, the main important aspect, the most important aspect. It also improves performance by making bundles smaller and by streaming server responses. So final disclaimer, all the demos were done with Next.js. Next.js is the only framework right now that is implementing React Server components. And that's probably something that I don't like too much. But there are other frameworks, React-based frameworks, which announce that they will support React Server components in the future. If you are learning React components or analyzing it like I did, it's quite frustrating because Next.js has some features which are proprietary to Next.js. And then there are some stuff that is like standardized from React Server components. And it's often very difficult to find out which is what. That was it. Thank you for having the patience to stay with me.
Thank you very much.
Any questions?
Right, so we are over time, but because this was the last one, so we have this liberty. So if you want to ask questions, we can do that, right? There's no other speaker coming. First question, like, why?
Everything you presented here works out of the box with HTTP 1.1?
Yes.
Okay.
Yeah. Well. Streaming, I'm not so sure about it. Yeah, actually, I'm not 100% sure. Yeah, I didn't think about that. Yeah.
With that closure being serialized, like how does it play out, like with realistic data sets? Like in terms of like how much traffic are we sending over the network if we are serializing like closures which are accessing like realistic data sets from the database, right?
Yeah. I don't see that much of a problem there because you would load the data in the client anyway. So with the closure, I don't have that much a problem. I've rather a problem with the RSC payload anyway, because you have seen when I navigate here, I have a chatty interface with my so if I go here and if I would look at the network request here and I click here, then you see each time I click, I once again get the whole payload from the backend as this serialized payload, as these instructions basically. So in a client, in a pure single page application, this wouldn't happen. So I have more traffic going on and I have more server resources I'm using, that's for sure. And some conspiracy theory could say that this is a framework, Next.js is a framework that is sponsored by Versal, and Versal is a cloud provider, so they have interest in people using server resources.
Also, just a quick question. You said those server actions, they generate endpoints on the fly, basically. How does the network traffic look for those? Like, what kind of endpoints are those?
Yeah,
you shown in the network tab, right?
Yeah. So let's go here, and now if I update, you see there is a post request going on, and if you look at it, then we see that's the return. The return is again a RSC payload, which says how to update the UI, and the request itself, it sets down some proprietary instructions that are then deserialized. So,
can we see the URL, please?
Sorry?
URL. Like what kind of URL is generated?
This is something like that. No. Yeah, more. It is like that.
Must be fun to debug.
Yeah. But I think the philosophy is really, I mean, when we are doing single page application, we are living in the browser tab. We are living in, we just filter for probably for fetch requests, and we are looking how the front end talks to the back end. But if you are talking to a .NET developer who is using Blazor, or if you're talking to a Vaadin developer who is using Vaadin, he is not living in the browser tab. He is living just by having breakpoints on the server. And of course, I can also do that. I can go in here and I can, probably I don't do it for the time, but I can have here a breakpoint here, and then I'm landing there. And that's the entry point for my debugging experience. Should be, of course. If it's leaky abstractions and we get problem, then we are a bit lost. I mean, yeah. But I think that should be the promise of the framework. The network communication, that's just an abstraction level higher. We don't care about it. If that's going on or not, that's a question. Yeah. Going to work out. That's a question.
We have one more.
Thank you. You showed us the example where you passed a function which was fetching data on the server side. It was declared as use server. I think. What happens if you omit that, if you forget about it? And are you sending the data URL and secrets to the client, or
that's a problem, yeah. So there are two things. So one thing is if you are using some APIs in that code that you don't have available on the client, then the bundler will already tell you. So if I would do that and I'm using SQLite there, then it would already, while bundling, it would say that is not possible. I can't do a bundle that actually has that. With the secrets, that's actually a problem that you can expose unwillingly something, but they have this thing here. That's also maybe a workaround. They have made a package when the bundler hits that import statement, then the bundler throws an exception. So that's their solution to, if you have something that you want to make very sure that it's never be sent to the server, to the client, then you import this server only, and then the bundler will never include that code.
Thank you.
Do we have more? If not, then thank you very much. It was an amazing talk.